Welcome to another episode of Tech Talks. I am your host, Justej Matharu. Today, I am going to be talking about my thoughts on main battle tank design. If you look at a tank, it has everything that a vehicle has got, and then a lot more. I will talk about the battle tank ground upwards. Something like if you were to talk about a car tires upwards. First and foremost, what is in touch with the ground? It is the running gear, which consists of the tracks and bogie wheels which ensure that the tank is able to move. Running gear gets its drive from a sprocket. The sprocket is connected from the engine compartment. And in order for the tracks to go around smoothly, on the other end of the tracks, we have an idler, which allows the track to go around and lay itself below the road wheels, which, as I mentioned, are also called bogie wheels. In order to hold the tracks on the bogie wheels, we have something called a horn, which is there on every track link, and the bogie wheels are in pairs. The horns are going through between the bogie wheels. That is why when the tank is turning, the tracks do not come off, or in the language of armored fighting vehicles, the tracks do not shed. The bogie wheels are in turn connected to the hull of the tank through the suspension system. Typically, the suspension system has got axle arms with some sort of a suspension mechanism which absorbs the shocks from the ground. As the tank moves, there is a combination of a spring and a damper in every suspension. The purpose of the spring is to absorb the shock, and every time the tank hits a bump, the spring compresses and does not transmit the shock directly to the hull. In addition to this, so that the tank does not keep bobbing up and down, we have the shock absorber, or what we call the damper, which dampens the up and down bobbing of the spring. With this system, we get connected to the hull, and there are a variety of suspension systems. They can be coil spring, pneumatic spring, or other designs. Now, let's move on to the hull. Typically, the hull of a tank is divided into three parts. In front is the driver's compartment. There are tanks which have got the engine right in front, but usually it is the driver's compartment. Then we have the fighting compartment, and in the rear of the tank, we have the engine compartment, from which the drive goes out to the sprocket which I had mentioned earlier. The driver's compartment, since it is only having the need of holding a driver, normally has space on either side of the driver. This space can be used for storing ammunition or fuel or batteries. Behind the driver's compartment is the fighting compartment. The main element which is there in the fighting compartment is the turret. In this compartment, you would have three people: the commander, the loader, and the gunner. Certain tanks have an automatic loading system. In that case, the loader is not needed, and the fighting compartment has only the commander and gunner. New tanks are coming up which will have no one in the fighting compartment. It will be all automated. Behind the fighting compartment, we have the engine compartment. Between the driver's compartment and the fighting compartment, there is really no separation and there is no bulkhead. The driver can exit out of the fighting compartment, and the commander and loader can exit out of the driver's compartment. But between the fighting compartment and the engine compartment, there is a bulkhead. The purpose of the bulkhead is to totally isolate the engine compartment for obvious reasons, because the engine will have gases and fuel and fumes which are not good for the crew. So the engine and crew are kept separate. This bulkhead has various features. For example, it will have inspection plates from where we can peer into the engine compartment, especially during maintenance. And it will have a number of wires and looms and pipes going from the fighting compartment to the engine compartment. For electrical connections, normally sockets are used. The engine compartment has the engine, the transmission, and the final drives, which in turn connect to the sprockets. The sprockets get the drive from the final drive and then run the running gear. The engine compartment has various systems: the engine itself, the lubrication system, the cooling system, the fuel system, the electrical system, the air intake system, the firefighting system, and other such systems. The engine compartment, as I said, will be enclosed and the cooling will be achieved through the means of a cooling fan. The cooling fan can achieve cooling in various ways. One way is where it throws out air from the engine compartment, creating a low pressure, and this results in air being sucked into the engine compartment through the radiators. Normally, there will be a number of radiators: water, oil, hydraulic, and such like. The engine compartment will also have an inlet for the air to the air cleaner, which will supply air to the engine inlet. There will also be a passage for the exit of the exhaust from the engine compartment. Usually tanks have diesel engines, but some have a gas turbine engine. Sometimes tanks have a main engine and an auxiliary engine. A word over here about the auxiliary engine and the starting system. Normally, the starting of a big engine takes a lot of current and drains the battery. So we could have an auxiliary engine which will recharge the battery. This is needed if the electrical starting is the main starting of the tank. However, in certain tanks, the starting is through air starting, in which case the auxiliary engine is dispensed with. In air starting, the main engine keeps the air bottles charged, and the stored air pressure is used for cranking and starting the main engine, thus conserving the electric charge of the battery. The purpose of the battery here is to give enough power for the tank to be able to operate its electrical systems with the main engine being switched off. If you had the auxiliary engine, that could keep running, as being smaller, it produces very little noise and heat. Starting the main engine would be a giveaway of your location. So having an auxiliary engine or not is a result of a balance which has to be made. Tank design is all about balancing one type of requirement with another. Coming back to the fighting compartment, the main thing which is there is the turret. The turret is mounted on a turret ring in the hull. The turret is able to rotate 360 degrees. The electrical connection of the turret to the hull is through some sort of a device like a rotary base junction, which is placed at the bottom of the turret, from where the turret rotates. In this manner, we achieve the supply to the main electrical systems of the turret. The main thing which the turret houses is the main gun of the tank. The main gun is a huge gun. Main guns of tanks fire very high velocity projectiles. So an important part of the design here is how to contain the recoil of the gun within the space of the turret. In the turret, there are two more important systems. These are the gun control system and the fire control system. The purpose of the gun control system is to allow the commander or the gunner to rotate the turret at will and to acquire targets. The purpose is to quickly swivel the turret around and bring the gun onto the target. The fire control system decides the manner in which the gun will be fired. Nowadays, tanks have the stabilizing system, which means irrespective of how the hull is moving, the gun remains locked onto the target. This is what makes the tank a very lethal weapon. A tank can move very fast and at the same time remain locked onto the target and fire accurately. This is the final aim of the designer of the tank. The gun itself can be rifled or smoothbore. The main purpose of the gun is to be able to fire a projectile which will defeat the adversary's tank's armor. So high velocity rounds are needed and a variety of ammunition has been invented for this. Coming back to the hull, it is very important for the designer to make a hull which is able to protect the tank from the adversary's projectiles. Here again, the issue of balance comes. Normally, the frontal part of the tank, which is known as the frontal arc, is heavily protected, and the top, sides, rear, and bottom less so. It is impossible to protect a tank heavily from all sides. A variety of armors have been developed. There used to be the monolithic armor, which was a chunk of steel. Now new armors have come up, which are designed to defeat projectiles without too much of a weight penalty. The classic balance a tank designer has to achieve is between the firepower, the mobility, and the protection. The running gear, the engine, and the sprocket all provide the mobility. The firepower is by the gun, its caliber, the speed of the projectile, accuracy of the projectile, and the ability to be able to move and fire. Protection is through the armor. It is obvious that if you want a bigger gun, it means it will be heavier and the tank's weight will go up. Similarly, if you want to increase the protection, the tank's weight goes up. If you want now to put a bigger, more powerful engine, you need more space in the engine compartment. This will make the tank's hull bigger, which in turn will again require protection. And so in tank design, one thing leads to another, and you have to strike an optimum balance based on your requirements. Various armies, according to their requirements, based on their own situations, have designed different tanks. A lot of technology goes in to ensure that you are able to get the optimum firepower, mobility, and protection as per your own requirements. It is expensive technology developed after tremendous research and development. In spite of the variety of other weapons, both on the ground and in the air, the main battle tank remains the most lethal weapon on the battlefield even today. Thank you very much for listening. We look forward to having you back with us in future episodes.